So looking at the first problems of our review for the first quiz out of chapter 5. Um, so just like when we're graphing standard form equations, anything that happens under the radical here has to do with side-to-side movement. And it is also the opposite of the sign that we see. So my point of origin is going to be right 2 because of this minus 2. And then it's going to go up 3 because of the 3 at the end. So my graph is going to start here, and then it's going to curve upward. That means that I'm going to have a domain, and remember, domain is list of all x values. Okay, it's going to start at positive 2. My range is going to start at positive 3. Now I have to check and see, are things getting bigger or smaller from this initial value? Well, my x is moving to the right, so it is greater than or equal to the 2. And my y values are also increasing here, so that is also greater than or equal to the 3. And looking at my Desmos screen, right, I can graph that here, and if I need to get that point of origin. So for the next problem, we have y equals the negative of square root of x minus 3, and then plus 4. So this here is still going to be side-to-side movement. That's going to move my vertex right 3, and then up 4. This negative out in front controls vertical because it's outside of the radical, so it's going to reflect it then across the, reflect it downward. That means that when I am working with my range, I have to remember that it is flipped. So for x, I see my x values increasing from the 3, so greater than or equal to 3. My y values, though, are decreasing, so that means y is less than or equal to 4. And again, I can get a picture of that on my Desmos screen. For graphing the inequalities, this one, number 5, is pretty straightforward because there are no coefficients involved. So I'm going to have origin here, right 2 because of this negative 2, and then no movement up or down because there's nothing after the radical. So that means I am going to get a graph that kind of arcs up and to the right. But I have to keep in mind this symbol, right? This is an inequality. So y is greater than the line. So that means when I graph the line, I need to use dashes. And then I need to remember then the shading for greater than would be above the line. Notice I started here at this origin that I'm kind of darkening. I did not color over here because that is not part of the graph. And again, I can graph that right in Desmos. They use green, I use red, but you get the idea. For number 6, we have a little more going on in number 6 because of this 2 with the x. So we will just go right to Desmos, and I see my origin here at negative 1.5 comma 4. So that's over here, up 4, 1, 2, 3, 4, about like that. Again, it's less than, so it's going to be the dashed line, not a solid line. And then I am going to color below. And again, you see on the purple Desmos graph how that shading ends right here at this origin, right? It does not color to the left of that. For number 7, switching from exponential form to radical form, we need to keep in mind that when we have a root, right, an nth root of x, we can rewrite that as x to the 1 over n power. So that kind of is our relationship between radical and exponential form. So for number 7, we have x to the 5/3. That means we need a radical. That's what that sign is called. And the denominator here, this 3, is going to be my n value. So I'm taking the third root. And I am taking the third root then of that, x to I will take the third root of x and then take that to the fifth power. And that 5 comes from this numerator here. For number 8, we're already in radical form. We want to switch to exponential form. So we want to get rid of that root sign. It's implied that it's a square root if there's no number there. So there's a little 2. So that means I'm going to take x, and then the denominator of my exponent will be a 2 from the square root right here. And then this 7 will stay with the x, and it will be the numerator. So for 9 and 10, we are evaluating those expressions. They are in exponential form. So what this is asking me in number 9 is to find the third root of 343. So what I can do to work this out really is just some guess, check, revise, or I can use a calculator. Desmos would work. Your handheld would even work. So I would personally just use guess, check, revise. I know 2 to the third power is 8. So I'm a long way from my target of 243. 5 to the third power is 125. It gets me closer. So I would just keep checking on my calculator. 6 is 216. And if I type 7 to the third in my calculator, that would be 343. So my answer here would be 7. Another way to do that would be in Desmos. Type it in 343 with that exponent of 1/3. You could also go into the functions tool and get the radical that has the box right here where you can type in, and that would be the third root. And it would also tell you that it's 7. So for number 10, 32 to the negative 2/5 power. So I'm going to deal with that negative right off the bat. I know that negative exponents are on the wrong side of the fraction bar. Right, so I have 1 over 32 to the 2/5 power. So I need to think about what number to the 5th power is equal to 32. It's actually the number 2 is 2 to the 5th power is 32, right? 2 times 2 again is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So the 5th root of 32 is 2. And so then I have 2 squared as a denominator. So my final answer would be 1 over 4. For number 11, we need to simplify square root of 45, a to the 15th, b to the 8th. So I'm going to start by looking at square root of 45. Now, 45 is not a perfect square, but if I factor 45 into 9 times 5, right, 9 is a perfect square. It's the largest perfect square that is a factor of 45. So that'll help me simplify that part. Square root of 9 would be 3. So that's going to come out from underneath the radical. The square root of 5 is going to have to stay under the radical because it can't be simplified. For square root of a to the 15th, right, if I want to look at just this part, I am going to take the exponent of 15 and I am going to divide it by 2 because this is a square root, right? So this n value right here of 2 is what I divide all the exponents by. So 15 divided by 2 is 7, remainder 1. The 7 is the exponent for a after you take the square root of it. So the square root of a to the 15th is a to the 7th, and then that remainder is going to go under the radical. So a to the first is going to stay under. Now, we don't typically write exponents of 1, so I don't really need that exponent there. The square root of b to the 8th, this part, I'm going to take the 8 and I am going to divide it by 2. 8 divided by 2 is 4. So the square root of b to the 8th is b to the 4th, and there is no remainder, so there is nothing left to put under for the b part of that problem. So the square root of 45a to the 15th b to the 8th would be 3a to the 7th b to the 4th times the square root of 5a. For number 12, I'm taking the cube root of m to the 9th, n to the 12th. That means I'm going to take these exponents and divide them now by 3 because it's a cube root. Right? So this 3 here tells me I'm dividing exponents by 3. So 9 divided by 3, this 9 from m to the 9th is 3. And then n to the 12th, I take the 12 and divide it by 3, and I get 4. For number 13, I'm going to start off by multiplying things on the outside of the radical. 6 times 2 is 12. And then underneath the radical, I'm going to multiply 6 times 3 is 18, x squared. Right, so I multiply things underneath and things out in front. Before I can call this done, I need to check 18x squared and see if I can take the square root of any of that. So 18 could be written as, square root of 18 could be written as square root of 9 times 2, right? Because 9 is a perfect square. So square root of 9 is 3, and the square root of the x squared is x. So the x can come out as well, leaving just a square root of 2 underneath, right? From this part right here, it's not a perfect square. One last simplify step, I'm going to go 12 times 3 and get 36, and it's with an x, and then square root 2. For 14, I am going to basically do a modified combined like terms. Right? I have 5 square roots of x minus 2 square roots of x. So I'm going to subtract the 5 and the 2. 5 minus 2 is 3. And we're talking about square roots of x. For 15, our exponent properties say that when we have a base, they both have an exponent, we can add those exponents. So I'm going to add the 2/3 and the 7/3. Me x to the 9/3. I should go ahead and simplify the 9/3. Right? 9 divided by 3 is 3. So my final answer there is x to the 3rd. For number 16, I need to simplify each part of this. Right? So I'm going to simplify the 15 over 3. Right? I know 15 over 3 is 5. Right? So 5 over 1. And then I'm going to work to simplify each of the variables, right? So I have a to the negative 6 over a squared. And that negative 6 on the a, right, a to the negative 6, right, that term's on the wrong side of the fraction bar. So I need to move that a to the 6 to the bottom, and I would add the exponents then. So I would get a to the 8th for b to the 4th over b to the negative 5, right? This negative here tells me that needs moved up, and I will add the 4 and the 5 to get b to the 9th. And then c to the 3rd, or c to the 6th over c to the 3rd means I am going to subtract those exponents, and I get c to the 3rd. Right, so my final answer is 5b to the 9th, c to the 3rd over a to the. Solving radical equations here to finish out the review. When we have a radical, in this case it's a square root, we need to get the radical by itself. and then remove the radical. And to do that, we take each side to whatever the n value is on that radical, and then we solve for the variable. So here on number 17, right, this is a square root. So to get rid of this whole radical here, we would take both sides and square it. So 5 squared is 25. And then the 2n plus 1 is just going to move down. Right, then I can just do all my regular algebra here to work to get n by itself. And finish out dividing both sides by 2. I get n equals 12. For 18, I have square root of k minus 1 and then minus 3 equals 7. I need to get the radical by itself, so I will start off by adding away this 3. And so I get square root of k minus 1 equals 10. Right, this is a square root, so to get rid of that, I square both sides. Right, get k by itself, I add away the 1. I get k equals 1. For number 19, I have a square root on both sides. And that tends to confuse people just a little bit. But if I just looked at the right side, square root of z plus 8, if I wanted to get rid of that square root, right, I would just square both sides, right? And by doing so, by squaring both sides, right, I actually, in this case, I get rid of both of the radicals. Right, so that leaves me with this 3z minus 2 equals z plus 8. Right, these are z's. So then I can subtract this z over. I get 2z minus 2 equals 8. I can add away this 2. Gives me 2z equals 10. Dividing away the 2 to finish it out, I end up with z equals 5. And then number 20, this is actually an exponential form. 2d plus 6 all to the 1/3 power equals 2. Right? I need to get rid of that 1/3 power. And to do that, I need to take it to something that when I multiply the 1/3 by something, right, I get a 1. So that would be 3, right? Whatever your n value or that denominator is, that's what you're going to multiply. That's what you're going to multiply the exponent by. So you want to take both sides then to the 3rd power, because then with the power of a power, then we multiply the 1/3 and the 3. So that gives me 2d plus 6 equals 8, right? 2 to the 3rd is 8. Remember, it's not multiplying, it's an exponent. Subtract away the 6. 2d equals 2. So after I divide away the 2, I get d equals 1.